Hello dear students, in this video I'll continue with the 7th unit Financial Mathematics. Here we will see the calculation of EMI, which is equated monthly installments, using two methods. The first one is flat rate method and the second one is reducing balance method. I'll also solve the questions from exercise 7.3 of CBSE Handbook. Now before entering into the calculation of EMI, we will see what is loan. I think everyone is familiar about the term loan. A loan is nothing but it is an amount which is borrowed from a lender with some interest. So if you see, many people have to borrow money or they have to take loan for certain contingencies. Not everyone will have sufficient money always. Say for example, if a person wants to purchase a car or a house or for setting up a new business, then loan is obtained. Now this loan, it is repaid by the borrower to the lender within a specified length of time. So how this loan is repaid? It is basically repaid using equated monthly installments. Now we will see some of the basic terms related to EMI or equated monthly installments. The first we have what is called principal. Again, we are familiar with this term principal. It is the initial amount of money which is borrowed or it is invested. And then we have interest. Interest is the price which is paid by the borrower for the use of lender's money. So if you see total interest, it is nothing but it is a difference between the initial amount which is borrowed and the end payment which is made to the lender. And then we have the rate of interest. Rate of interest, it is the percentage of the sum which is borrowed and it is charged for a defined length of time for using the principal, generally on an yearly basis. And next we have the term of loan. Term of loan, it is the length of time within which the borrower has to repay the money to the lender. It is the defined length of time it will take for a loan to be completely paid off when the borrower is making regular payments. Now during this term of loan, the principal and the interest should be repaid. Now moving on to EMI. EMI, it stands for equated monthly installment. So it is a monthly installment that we have to make towards a loan which we have opted at a fixed date of every month. So it is a very usual term which is used nowadays. A loan is said to be amortized if it can be discharged by a sequence of equal payments which is made over equal periods of time. And here each payment, it is considered as consisting of two parts. One is the interest on the outstanding loan and the other one is repayment of part of the loan. So if you take EMI, it consists of two components. One is the interest on the outstanding loan and the other component is repayment of the principal. Some part of the principal. It is repayment of part of the loan. And now we will see the methods of calculation of EMI. The first one is flat rate method. In this flat rate method, each interest charge is calculated based on the original loan amount. Although the loan balance outstanding is gradually being it is paid, although this is the case, each interest charge, it is calculated based on the original amount. So we take the total interest on a flat rate. So if we take, let P, I and N be the principal of the loan, the total interest on the principal and number of months in the loan period respectively, then the EMI is given by the formula EMI is equal to P plus I upon N, where P is the principal of the loan, I is the total interest on this principal and N is the number of months in the loan period. EMI is calculated using this formula under flat rate method. And now moving on to the reducing balance method. Now we will see the amortization formula. When one is amortizing a loan at the beginning of any period, the principal outstanding is the present value of remaining payments. So if a person is amortizing a loan, then the principal which is at the beginning of any period, it is nothing but it is the present value of all the remaining payments. So if we take the amortization of an interest-bearing loan of rupees P at a rate I per period by n equal payments of rupees R each, and such that a payment is made at the end of each period, it is given by. So if we are amortizing the amount P by, we have R equal payments. So the EMI is R, which is made at the end of each time period for a period of, say, n, and the rate per period is given by I. Then this P is the present value of each of these payments. So P is given by the present value of R, which is made at the end of the first time period, which is R by 1 plus I, plus the present value of this R made at the end of second time period, R by 1 plus I the whole square, plus up to etc. plus R by 1 plus I the whole raised to n. So here we can see that this is a geometric series where the first term is R by 1 plus I and the common ratio is 1 by 1 plus I. So using Sn is equal to A into 1 minus R raised to n upon 1 minus R. Here A is R by 1 plus I into 1 minus common ratio is 1 by 1 plus I the whole raised to n, the whole thing divided by 1 minus 1 by 1 plus I. So this is R by 1 plus I into 1 minus 1 plus I the whole raised to minus n, the whole thing divided by 1 plus I minus 1 upon 1 plus I. So these two will cancel, plus 1 minus 1 will go. So it is R into 1 minus 1 plus I the whole raised to n, whole raised to minus n upon I. Now this 1 minus 1 plus I the whole raised to minus 1 upon I, it is nothing but it is the present value annuity factor, and it is denoted by A for n number of periods and I rate per period. Now this notation is usually used in actuarial science. It is nothing but it is the present value annuity factor for n number of periods and I rate per period. So we have got a relation between the outstanding principal amount and the EMI. So from this we can find EMI as R is equal to P upon A for n number of periods and I rate per period. So this is how we can find EMI. If we take the case of, it is similar to valuation of bonds, where we know each of these interest payments and the maturity value, we will find the present value of each of these. That is, we will find the purchase price of the bond V using the interest payments and the maturity value C. So we will be the present value of these interest payments and the maturity value C in case of valuation of bonds. Whereas here in loan amortization, we know the principal amount. This principal amount is the present value of each of these equated monthly installment which is made at the end of each month for a period of n. So using this relation, we can find the EMI as R is equal to P upon present value annuity factor for n number of periods and I rate per period. So this is how we can find the EMI. Now let us write some more formula. So we just now saw the periodic payment or installment. It is given by R is equal to P upon ANI. AN, this is nothing but it is 1 minus 1 plus I the whole raised to minus n upon I. So this is equal to P into I by 1 minus 1 plus I the whole raised to minus n. And then we have another formula, principal outstanding at the beginning of kth period. Now if you want to find the principal outstanding at the beginning of kth period, then it is given by R into 1 minus 1 plus I the whole raised to minus n plus k minus 1 upon I. Now say for example, if you want to find the principal outstanding at the beginning of 4th time period, it means 3 installments have already been paid and we want to know the principal outstanding at the beginning of 4th time period. So we have to reduce the present value of these 3 installments. So what happens is, here we will have 1 minus 1 plus I the whole raised to minus n plus 4 minus 1. So it will be minus n plus 3 upon I into R. It will give the present value of principal outstanding at the beginning of 4th time period. Similarly, the principal outstanding at the beginning of any time period can be found using this formula. Then the next formula is finding the total interest paid. Now if R is the size of each equal installment, then this R, it will consist of both the interest and the principal. So the total interest paid will be n into R minus the principal amount. So n into R minus the principal amount, it will give the total interest paid. Now moving on to the questions from exercise 7.3. The first question, Mohan takes a loan of rupees 5 lakhs with 8% annual interest rate for 6 years. Calculate EMI under flat rate system. So here Mohan takes a loan of rupees 5 lakhs, this is the principal, with annual interest rate, this is I, this is small I, for 6 years. So we need to find the EMI under flat rate system. So first let us write what is given. Given P is equal to rupees 5,000 and the annual interest is 8%. So the total interest will be, this is 0.08. The total interest for the entire time period, it will be this 8% of the principal for each year. It is repaid in 6 years. So it will be 8% of this 5 lakh into 6. So it is 8 by 100 into 5 lakhs into 6. Because in flat rate system, we take the interest to be equal for every year. So for 1 year it is 8% of 5 lakhs. For 6 years it will be 8 by 100 into 5 lakhs into 6. So this, when we simplify, we get it as rupees 2,40,000. And n is given as 6 years. Here we need to find EMI. So for each year we have to make 12 equal payments. So for 6 years we have to make 6 into 12, 72 equal payments. So n is 72. Now EMI is given by EMI is equal to principal plus the interest upon n, or the principal is 5 lakhs plus the interest is 2,40,000 and the total number of periods is 72. So this is 7,40,000 upon 72. So it is rupees 10,278 approximately. Therefore, EMI is equal to rupees 10,278. So for a loan of rupees 5 lakhs with 8% annual interest rate for 6 years, The EMI under flat rate system is rupees 10,278. Moving on to the next question. XYZ company borrows rupees 3 lakh with 7% annual interest rate for 4 years. Calculate EMI under reducing balance method. So here the principle is given directly. So first let us write what is given. Given P is equal to rupees 3 lakhs. I is equal to 7% upon 12. Now here 7% is the annual interest rate. While calculating EMI, we have to compound it monthly. So the rate per period I is given by 7% upon 12. So it is equal to 0.07 upon 12. It is 0.00583 approximately. And N is 4 years into each year has 12 months. So it is 48. So we have written what is given. Now we need to calculate the EMI. EMI is given by EMI is equal to P upon present value annuity factor for n number of periods and I rate per period. It is equal to P into I upon 1 minus 1 plus I the whole raised to minus n. So it is here P is 3 lakhs. I is 0.00583 upon 1 minus 1 plus 0.00583 the whole raised to minus 48. So we have EMI is equal to here this 3 lakh into 0.00583. It is equal to 1749 upon 1 minus 1.00583 the whole raised to minus 48. Now the value of this will be usually given in the question. The value of 1.00583 the whole raised to minus 48 is 0.7564. So it is equal to 1749 upon 0.2436. Now this when we simplify, we get it as 7179.8. Therefore, EMI is equal to 7179.8 rupees. So this is the EMI using reducing balance method for principal rupees 3 lakhs with 7% annual interest rate when the loan is repaid in 4 years. Moving on to the next question. Rajesh borrows rupees 6 lakhs with 9% annual interest rate for 5 years. Calculate EMI under reducing balance method. So first let us write what is given. P is rupees 6 lakhs. Then the rate per period will be 9% upon 12. So it is 0.09 upon 12, which is 0.0075. Then N is 5 into 12, which is 60. Now we have the formula. EMI is equal to P upon present value annuity factor for n number of periods and I rate per period, or it is equal to P into I upon 1 minus 1 plus I the whole raised to minus n. Now let us substitute the values and find the answer. So EMI is equal to P is 6 lakhs into I is 0.0075 upon 1 minus 1 plus 0.0075 the whole raised to minus 60. So it is equal to 6 lakhs into 0.0075 upon 1 minus 1.0075 the whole raised to minus 60. So this is equal to 6 lakh into 0.0075. It is 4,500 upon 1 minus the value of 1.0075 the whole raised to minus 60. Usually given in the question, it is 0.6387. So this is equal to 4,500 upon 0.3613. Now this when we simplify, we get it as 12,455 approximately. Therefore, EMI is equal to rupees 12,455. Next question. A person amortizes a loan of rupees 1,50,000 for a new home by obtaining a 10-year mortgage at the rate of 12% compounded monthly. Find the monthly payments and the total interest paid. So here a person amortizes a loan of rupees 1,50,000 by getting a 10-year mortgage and the rate is 12% compounded monthly. We need to find the monthly payments and the total interest paid. So first let us write what is given. Usually such type of questions carries 4 marks. How the allocation of marks is done, we will see after completing this. So given P is equal to rupees 1,50,000. Then I is equal to, it is given 12%. Monthly payments should be made. So I, the rate per period, it is 12% compounded monthly. So it is 12% upon 12, which is 0.12 upon 12. It is 0.01. And then we have N is 10-year mortgage. So 10 into 12, it is 120. Now let us write the formula. We have EMI is equal to, this is the first subdivision, the principal amount upon the present value annuity factor for n number of periods and I rate per period. It is P into I upon 1 minus 1 plus I the whole raised to minus n. So it is equal to 1,50,000 into 0.01 upon 1 minus 1 plus 0.01 the whole raised to minus 120. This implies. So 1,50,000 into 0.01, or let us keep it as it is. It is 1,50,000 into 0.01 upon 1 minus 1.01 the whole raised to minus 120. So we have EMI as 1,50,000 into 0.01. So here 1.01 the whole raised to minus 120, the value is given as 0.30299. So it is 1 minus 0.30299. So it is equal to 1,50,000 into 1.01 upon 0.69706. I'm sorry, 0.01. Now this when we simplify, we get it as approximately 2,151.9. Or we have EMI is approximately equal to rupees 2,152. So this is the monthly installment or the monthly payments. Then the second subdivision is total interest paid. Second subdivision, total interest paid is equal to N into R minus P. R is nothing but it is the EMI. So it is equal to 120 into 2152 minus 1,50,000. So this is equal to 2,58,240 minus 1,50,000. So this is equal to rupees 1,08,240. So they have asked to find the monthly payments and the total interest paid. So the monthly payments is 2,152 and total interest paid is 1,08,240. So writing what is given, finding the amortized amount, all these carries 1 mark. Then writing the formula carries 1 mark. Then finding EMI carries 1 mark. And finding the total interest paid carries 1 mark. So similar question was asked in sample paper for 4 marks. Moving on to the next question. A couple wishes to purchase a house for rupees 12 lakhs with a down payment of rupees 2,50,000. If they can amortize the balance at 9% per annum, compounded monthly for 20 years, what is the monthly payment in rupees and what is the total interest paid? Given present value annuity factor for 240 periods and 0.0075 rate per period is 111.1449. So here we have the value of this present value annuity factor which is given in the textbook. So I thought we can use this value to find the answer for one question. So here it is given a couple wishes to purchase a house for 12 lakhs and down payment is 2,50,000. So they have to get a loan for the difference of these two amounts. So the amortized amount will be 12 lakhs minus 2,50,000 and then the interest rate is 9% per annum for 20 years. We need to find the monthly payment and the total interest paid. So first let us find the amortized amount. That is the amount for which loan should be obtained. Amortized amount P is equal to 12 lakhs minus 2,50,000. So it will be rupees 9,50,000. Then the rate per period is 0.09 upon 12. So it is 0.0075 and the number of periods n is 20 into 12. So it is 240. Now we know the formula for EMI. We have EMI is equal to P upon ANI. Here since we are given the value for this present value annuity factor, I am substituting it directly. Or let me write the formula alone again. I by 1 minus 1 plus I the whole raised to minus n. So this implies EMI is equal to P is 9,50,000 upon 111.1449. So this comes to be approximately 8,547.26. Therefore, EMI is equal to rupees 8,547.26. And now the total interest paid will be total interest paid is equal to N into R minus P. So it is 8,547.26 into 240 minus P is 9,50,000. So this is equal to 20,51,342. minus 9,50,000. So this is equal to rupees 11,01,342. So this is the total interest paid. Now we have studied one formula to find the principal outstanding at the beginning of kth period. Now we have taken this example question where we can use that formula and find some values. So this is from the CBSE Handbook. Mr. M borrowed rupees 10 lakh from a bank to purchase a house and decided to repay by monthly equal installments in 10 years. The bank charges interest at 9% compounded monthly. The bank calculated his EMI as rupees 12,668. Find the principal and interest paid in the first year. So here we are given the principal amount, that is the amount for which the loan has been amortized, then the time period and the interest which is compounded monthly, and EMI is also given. We need to find the principal and interest paid in first year. And we are given the present value annuity factor for 108 number of periods and rate per period 0.0075 as 73.83916. So first let us write what is given. Given P is rupees 10 lakh. Then the rate per period I is, it is 9% compounded monthly, so divided by 12, so it is 0.0075, and N is, it is 10 into 12, which is 120. Now we know the formula for principal outstanding at the beginning of kth period, so it is given by, and R is also given, EMI is also given. R is rupees 12,668. So it is R into 1 minus 1 plus I the whole raised to minus N plus K minus 1 upon I. And now we need to know the principal which is paid in the first year. So it means EMI has been paid for 1 year, which is 12 EMI has been paid. So the principal outstanding at the beginning of 13th period will be principal outstanding at the beginning of 13th period. Using this formula, it will be R into 1 minus 1 plus I the whole raised to, here N is 120, so minus 120 plus K is 13 minus 1, 12 plus 12 upon I, or it is equal to, R is 12,668 into 1 minus 1 plus I is 0.0075 the whole raised to minus 108 upon 0.0075. And now this is nothing but 1 minus 1 plus 0.0075 the whole raised to minus 108 upon 0.0075. It is the present value annuity factor for 108 number of periods, and rate per period is 0.0075. So this is given here. So this is equal to 12,668 A 108.0075. So this is 12,668 into 73.83916. Now this, when we simplify, we get this as approximately equal to rupees 9,35,395. So the principal outstanding at the beginning of the second year, that is after 1 year principal and interest has been repaid. It is 9,35,395. So the principal paid during the first year, it will be rupees 10 lakh minus this amount. So principal paid during the first year will be 10 lakh minus 9,35,395, or it is equal to rupees 64,605. So this is the principal which is paid during the first year. And then next we have interest which is paid during the first year. So the interest paid during the first year will be the EMI into 12, because in the first year the EMI for 12 months has been paid. So interest during the first year will be this EMI into 12 minus the principal paid during the first year will be the interest paid during the first year. So it is equal to 12,668 into 12 minus 64,605. So this, when we simplify, this is equal to 1,52,016 minus 64,605. Now this is equal to rupees 87,411. So the principal paid during the first year is 64,605 and the interest paid during first year is rupees 87,411. So this is how we can use the principal outstanding at the beginning of the kth period formula to find the principal and interest which is paid during any period of time. I hope this video was useful for you. The topic of calculation of EMI is very important. Thank you for watching.